Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to build a confusion matrix. So quickly I'm going to give you a preview of the data set. So I've already done a logistic regression model, and in a different video I show you how to do a logistic regression model for multi-class classification. And this is the variable that we use to store our predicted class. Our predictions is stored in this variable. So I'm going to be using this variable to do the confusion matrix. So when you see this, don't get confused. This is my predictions from logistic regression model that I did. And of course, you can use any model, but for this example, I'm using logistic regression. So what is confusion matrix? Confusion matrix is a technique used to explain classification models. That's kind of like the best way for me to explain it in layman terms. It's a metric, is a, think of it as a report where you have like where you get like many different information about your model. So this is the scikit-learn confusion matrix documentation, and it evaluates the confusion matrix and uses it to evaluate the accuracy of the classification model. And then if you go down here, this is kind of like the parameters. You provide the true value and then the predicted value, and you can provide labels if you want, and then it returns the confusion matrix. So that's just a quick preview of the confusion matrix. With that being said, let's go ahead and dive in here. So we do from sklearn.metrics import confusion matrix. And to do a confusion matrix is very simple. You just type in confusion matrix and then you provide your true value. In this case, my true value is y test, and my predicted value is ypred lr2. And let's go ahead and run this. In a nutshell, that's basically it. Ta-da! We are done. No, I'm just kidding. This right here is very, very difficult to read, and it's difficult to make any conclusive information from just looking at this. Okay, so let me go ahead and do xtrain.head. And so this is like what my data set looks like. This is predicting wine quality, and if I do y train.unique, it basically tells me how many unique items are there. So as you can see right here, there are 7 unique categories in this in this classification problem, and that's why we have 7 rows and 7 columns. So just looking at this, it's kind of difficult to know which row here belongs to which class and which column belongs to which class. So this doesn't look very useful, but don't worry, we are going to fix that. So let's start by getting data frame labels. So from sklearn.utils .multiclass import unique labels, and then from here if we do unique labels, and let's see unique labels in our y test. And so as you can see, this is the same thing that we have right there. So this is another way to get the unique labels if that's what you really wanted. The only thing is that this one gives you unique labels in ascending order, from smallest to highest, and this gives you the unique label in random format. So let's go ahead and then combine these labels with the confusion matrix. All right, so basically this right here is our confusion matrix. This is our labels. We're gonna take this and combine it with this so it's easier to read the confusion matrix. All right, let's get coding. So we're just gonna create a function. Let's just call it plot, and let's provide our y true and y spread as our parameters, and let's do labels is equal to unique labels from our y test that we provide, and then our columns will be equal to for label in labels. Okay, so basically right here, right, label is unique parenthesis y test, which is the same thing right here, and it's a list. Okay, so the names of our column is going to be predicted and then 3, and then predicted 4, predicted 5. So it's gonna be a predicted label for each label in this list, which is this list. We are gonna do something similar for our index, and let's call it index, and let's call it actual. Same thing here. And now we are just gonna create a table to bring everything together. So PD stands for pandas, and so if you see abbreviation, earlier I did import pandas as PD. Okay, so that's what this PD stands for. And I want to create a data frame using this, the confusion matrix, and I want the columns to be equal to columns. And then I want the index to be equal to index. So basically, let me put this on the next line. So basically here, I'm creating a data frame, and the data that I'm going to be using for the data frame is the data located in the confusion matrix. Okay, so if I hover over this, right, the first thing that you provide in the confusion matrix is the true value and the y spread. But if you hover over the data frame, you can see the first thing you provide is the data, and then the next thing you provide is the index, which is kind of like the rows, and the next thing you provide is the columns. Right, so we are saying that the data is the confusion matrix, the columns is these columns right here. I can just call this index column, just to make it clear, where this is coming from, because sometimes I know from personal experience, if this is columns right here and this is also columns and this is also columns, it might get confusing. So let's just call it column, and column just to make it clear where these variables are coming from. All right, this is just for clarification. You can call it whatever. So we said that we want our columns to be this, and then we want our rows to be this. That's what this index is for here. And then we just want to return table. So basically that is a function for combining our confusion matrix with the appropriate labels to make it easier to visualize. Now if we do plot, and let's say we pass in our y test and then pass in y spread LR and run this, and boom, that's what we have. Okay, we have predicted, I want space in between this, so we have predicted for this group, actual for this group, predicted for this group, actual for this group, predicted for this group, actual for this group. So basically this is our confusion matrix, which is the same thing as the one above, but with the attached labels, which makes it easier to read and comprehend. Now you can also create a heat map of this for you to have more visual reference, like without reading the numbers, you can quickly visually see what's going on with this confusion matrix. So let's go ahead and import seaborn as SNS. If you don't have seaborn in your environment already, make sure you go ahead and install seaborn in your environment. Either you're working in Jupyter Lab, VS Code, whatever. Make sure you have seaborn before you try to import it. So let's call it plot 2. Again, similar above. Actually, I'm just gonna go ahead and copy this because it is so similar to it. Like, there's not much difference between what I'm about to write and this. But let's call this plot 2 for clarification. Same thing, white true and white red, you provide your labels, you provide your columns, you provide your indexes, and then you create a table between the confusion matrix, the columns, and the indexes. And now, this is the only thing that is different. We do return sns.heatmap, and then when you do heat map from seaborn, the first thing you provide is the data, and then you can provide other arguments, and then you have the default argument here. You can leave it as it is, or you can change this. So the data is this table right here, and then we want to annotate. We want to set our FMT equal to D, and then CMAP to vary this or something else. And then we can go ahead and run this. And now let's go ahead and look at a heat map of this exact same thing. Boom. That looks really good. So basically this is the same thing as the heat map above, but this is the same thing as the confusion matrix above right here, but in a heat map fashion. So that looks pretty cool. That looks really good. Kind of like the color, the coloring scheme here. But this is how to build a confusion matrix, but how do you actually interpret it? So you can use confusion matrix to calculate precision, recall, accuracy score, and other metrics. You can calculate the true negative, you can get the true negative, the true positive, false negative, false positive, that should be false positive. So you can get the false positive numbers, and you can use this information to calculate the precision and recall. Then you can use the precision and recall to get the F1 score. But it will be so much easier to show you how to calculate precision and recall and F1 score using a binary classification confusion matrix. Okay, but before I show you how to do it manually, I'm going to show you how to get the precision, recall, and F1 score using a Sklearn library. And that is going to be on the next video. So on the next video, I'll show you how to interpret a confusion matrix plot. To get access to this notebook that I use in today's video, just go to machinelearningeducation.com. This is my primary website. Actually, this is my secondary website. And this is a platform I built just for data science. And if you go to free data science resources, you'll be able to get access to this notebook. I create a lot of YouTube videos and blog posts, and I end up with a lot of notebooks like this one, and I just find it more easy and straightforward to take all that notebook, all that content, and put it under one platform. So that's machinelearningeducation.com, where I put my free data science resources. And you can also visit me online at evidencen.com. That's my primary website where I have my data science blogs. And as time goes by, I'm going to add more stuff to my data science blog. And if you are here, you can also click on free data science resources to be able to get to this page. That's it for this video. If you like it, please give it a thumbs up and subscribe to the channel. If you made it this far in this video but you didn't like it, please give it a double thumbs down and still subscribe to the channel. Talk to you on the next video. Bye.